Today I want to work with you on our applications of 6 trigonometric functions. So if we're looking at, say, this diagram here, I'll have a prompt that I'm going to read that'll match up to the diagram. So take a look at the diagram as I'm reading the prompt. A 14.5 meter fire truck ladder, which is what we have here, is leaning against a wall. We want to find the distance the ladder goes up the wall, so we're looking for D in this case, above the fire truck if the ladder makes an angle of 42 degrees and 19 minutes with the horizontal. So we have our fire truck ladder, which we know our distance to. We also know that we have our horizontal here, which is making an angle of 42 degrees and 19 minutes, as well as the distance that we're trying to find. So one of the first things I like to do whenever I run into an application problem is to figure out what pieces of a triangle I already have access to. So first thing that I'm noticing is that I not only have the opposite of my angle, but I also have the hypotenuse of my angle. Is that ringing any of the bells associated to our 6 trigonometric functions? Hopefully you're thinking sine right away. So in this case, I can take the sine of theta is equal to the opposite divided by the hypotenuse. So I'm going to use the information that I have in my application problem and relate it to my trigonometric function that I've identified. So in this case, I'm going to go ahead and take the opposite length that I know, as well as my angle measure and the hypotenuse. And I'm going to substitute each one of those into their appropriate places based on the ratio. So I should have something along this line. Now you might be thinking to yourself, okay, that's great. What do I do now? Well, remember, we're trying to solve for D, right? We need that distance that the ladder is actually going to reach above that horizontal of the truck. So in this case, I'm going to go ahead and isolate D. I like to do all the algebra first to get it out of the way. So I'm going to multiply both sides by a 14.5 or 14.5 meters. So I'm going to end up with 14.5 meters times the sine of 42 degrees, 19 minutes is equal to D, which is exactly what we want. We want to solve for that distance. Now, knowing that information, I can go ahead and put this in my calculator, but there might be one additional step we need to think about. Remember this 19 minutes that we have? Well, remember, 19 minutes is equivalent to 19 divided by 60 degrees. Now when I put this in my calculator, I can get it all in one string. So I would write this as 14.5. Then I would put in sine, so this will be multiplied, of 42 plus, I'm going to open up a set of parentheses, 19 divided by 60. I'm going to close both sets of my parentheses. So I've got one set here and I've got one set here. And that's going to be equal to the distance. Now, once I've placed this into my graphing calculator, into my scientific calculator, whichever one you're using, you should be able to get the following decimal. So you're going to end up with 9.761800707 approximately. Now, given this problem, we probably don't want to have all the decimal pieces here. So in this case, let's go ahead and round to the nearest, let's round to the nearest hundredth, or the second decimal place there. Now, in doing so, I'm going to need to look at the value right next to it. So you're going to see that value right next to it is the number 1. Now, that 1 tells us that we're actually going to need to round down. In other words, we're going to get rid of all the rest of those decimals that we see there. So in this case, my final answer for the distance that ladder can reach is going to be 9 76/100ths of a meter, approximately. I hope you found this video helpful in using application problems with our 6 trigonometric functions.